Question number 81. Which of the following methods can be used for the preparation of benzene? The first one, by passing ethyne through red hot iron tube. Yes, this is the method of preparation of benzene. What happens here? In this case, you take this way, and there is the formation of bonds in this way. Now, here red hot iron tube you are taking, in which this process is taking place, and there is the formation of benzene ring in this way. By which method? By this method you can prepare benzene. Further, on heating sodium benzoate with soda lime, sodium benzoate, that is COONE. This is sodium benzoate, and it is treated with soda lime, that is NaOH, in the presence of CaO, and there is the formation of benzene, as along with that Na2CO3 is released. After this is also the correct method of preparation of benzene. Further, by passing vapors of phenol over heated zinc dust. If you take phenol and zinc dust is there, on which this vapors of phenol are passed, then definitely benzene would be formed. Along with that, ZNO is released. It means all three methods can be used for the preparation of benzene, and on that basis option 4 is the correct option. Let's take question number 82. Now question number 82. Incorrect statement regarding A and B is, we have alkyne that's given here, and in the first part Lindlar's catalyst is attacking over that to form A as the major product, and similarly in the second step there is sodium and liquid ammonia is attacking over that to form major product B. We need to just identify the products here. If we talk about Lindlar's catalyst, we know that that's a palladium that is absorbed over the carbonate, and here is the formation of the product, that would be C, double bond C, because alkyne is there and we are just providing hydrogen to it to form alkene from it, and there's the formation of an alkene of this type. This is A. What about B? If we talk about B, I'm just drawing its structure also. In the presence of sodium and liquid ammonia, there's the formation of, once again, the alkene, and this type of alkene you will obtain. If you look at the molecular structure of these two, this A and this B, you will identify that these two are the isomers. These are geometrical isomers basically. This is the cis form and this one is the trans form. Now let's check the options also. You need to choose the incorrect statement from that. So first option we have here, A and B both decolorizes brown color of bromine. Definitely it will be done by these two compounds, because these A and B both are alkenes and they are able to decolorize bromine water. Now let's check the given options also regarding A and B. A and B both decolorizes brown color of bromine. If we look at A and B, we will identify that these two are alkenes and they are able to do so. That's why they are doing so. I'm just marking a tick here. Then A and B are geometrical isomers. We know that these two are geometrical isomers. One is cis isomer, other is trans. That's why this statement is also correct. Third one, A and B both have zero dipole moment. We should always know that if we talk about the cis form, then definitely mu value is not equal to 0, because this is creating a dipole. But if we talk about B, that's a trans form, and in that case dipole moment becomes 0. Now on the basis of this statement is incorrect. Further, next statement, A and B both give electrophilic addition reaction. Definitely it is possible here, because these two are the alkenes. Electrophilic addition reactions are possible, and that's why this statement is also correct. Only one incorrect statement is given here, and that is in option 3. So answer for this question is option 3. After this, there's another question. Question number 83. In the following reaction, we have this reaction in which concentrated nitric acid and concentrated sulfuric acid are added to form a product X. If these two reagents are added to the aromatic compound, there is the process of nitration. Electrophilic substitution reaction is that, and nitration is the process that's taking place. After this reaction, there's the formation of the product, and you need to just identify the major product, X in this case. If you look at first option, there's the nitro group that is present on this benzene ring. Further, in the second option, nitro group is present on this benzene ring. We need to just check on which benzene ring this nitro group will attack. Simply, you should know that if we talk about electrophilic aromatic substitution reaction, then in that case, definitely this nitro group or the electrophile will attack on that ring that has more electronegativity, more electron density. So here is the oxygen atom that's present here, and it has lone pair of electron. That lone pair of electron increases its plus in effect, and due to which this nitro group will attack on this ring, on ortho position and at para position. And para isomer is the major product. That is why the product X would be this. I'm just drawing here its structure. And this is the carbon at which this nitro group is present in this way. And if it is so, where this is given here in option 2. That's why I'll choose this as the correct option. Question number 84. Most stable carbanion is. We have 4 options given here in which carbanions are given. You need to just find out the most stable carbanion. Carbanion means carbon with negative charge, and the negative charge is stabilized if it is present on an electronegative atom. We know that. If we look at all these carbanions, we'll see that negative charge is there at carbon atom, but the carbon atom with sp hybridized orbital is more electronegative. We know that electronegativity depends on S character of the hybridized orbital. So in case of first option, we have this sp hybridized carbon atom at which negative charge is present. It means negative charge is more stabilized here. That's why this carbanion is most stable, and on that basis, first option is the correct option. While in other options, it is not so. After that, question number 85. A compound having molecular formula C4H6 cannot be. If you look at this given compound, let's check. First, we have this compound in which how many carbon atoms are present? 4 carbon atoms. Let's provide them hydrogen also. Here is the hydrogen atom. There would be 2 hydrogen atom. Here 3. So total number of hydrogen atom in this case are 6. So this is having the molecular formula C4H6. Further, we have this compound. In this compound, 2 hydrogen atoms are in this way and 4 in this way. So C4H6, again the molecular formula is same. Further, in fourth one, 4 carbon atoms. 1 are there and 2 here. C4H6 once again. If we talk about this, in this case, here carbon in this way. So 1, 2, 3, 4 would be formed in this way. So this is the structure. In this case, the formula should be C4H4. That is not having the molecular formula C4H6, and that's why this option is correct for this question. After that, question number 86.